Okay, this lesson is on factoring trinomials, three terms. We're going to look at actually trinomials of this form, x squared plus bx plus c, where the leading coefficient here is a 1. And after we do a few examples of that, then we'll factor trinomials that have something other than 1 in the front. Okay, so these are the more simple type. Let's first take a look at this. If we have, let's say, x plus 5 times x plus 2, and we were to FOIL it out, we got x squared plus 2x plus 5x. This gives me a total of 7x plus 5 times 2 is 10. And so this this multiplies to that. Now notice the connection between the numbers. 5 plus 2 is 7. 5 times 2 is 10. And so I can use this to take a polynomial such as this and factor it. So I'm going to go in the reverse direction now. So here's what we do. First example here, let's say we have x squared plus 7x plus 12. And I want to factor the polynomial. Draw some parentheses. Now since this polynomial starts with an x squared, I know that I'm going to have an x and an x here because x times x gives me x squared. Now I'm going to take the number on the end, the 12, and I use this x here. You don't have to, but I find that it helps. And I'm going to put the positive 7 down here. And basically what I'm going to do is this. I'm going to look for two numbers. I'm going to look for two numbers that multiply to the 12, two numbers that multiply to 12 but add up to positive 7. And the two numbers that multiply to 12 and add up to positive 7 are 3 and 4, or 4 and 3, same thing. Those are the two numbers I'm looking for. So I'm going to put a 4 here and a 3 there. You could have them switched, it doesn't matter. This is the factorization of our polynomial, x squared plus 7x plus 12. If you were not sure that you did it correctly, of course, as I stated in a previous section, you would just FOIL this out and you should get the original problem back. And you would. Here's another example of this. Excuse me. X squared plus 6x plus 8. So since we do have an x squared here, I'm writing an x times x like that. I'm looking for two numbers that multiply to 8 here, but add up to 6. Two numbers that multiply to 8 but add up to 6, and those two numbers would be 4 and 2. 4 and 2. And so I'm going to put a 4 here and a 2 there, and I have it factored. There it is, just like that. Let's do some more examples. Okay, all of these were factoring. Factor. Oops, there we go. Y squared minus 2y minus 15. Let's try that one. Okay, since we do have a y squared in the front, I know this has to be a y times a y, like that. Now, I'm looking for two numbers that multiply to negative 15, but will add up to negative 2. Two numbers that multiply to negative 15 but add up to negative 2, and those two numbers would be, what would those be? Negative 5 and a positive 3. If I multiply them, I get negative 15. If I add them, I get a negative 2. So I'm going to put a minus 5 there and a plus 3 there, and I have it factored correctly. Let's try another one. Z squared minus z minus 12. Okay. Z times z. I'm looking for two numbers that multiply to negative 12, but will add up right here to a negative 1. That's actually a negative 1 there. Two numbers that multiply to negative 12, but will add up to negative 1, and those two numbers are a negative 4 and a positive 3. There they are. So I'm going to put those in there, minus 4 plus 3, and I have the polynomial, the trinomial factored. Here's some more. P squared plus 6p plus 5. P times P. Okay, I'm looking for two numbers that multiply to 5 but add up to 6. The two numbers that multiply to 5 but add up to 6 are 5 and 1. 5 and 1. So I put a plus 5 there and a plus 1 there. And it's factored again. Here's another one. A squared plus 9a plus 20. It has to be a times a in the front. What two numbers multiply to 20 but add up to 9? And those numbers would be 5 and 4. They multiply to 20 but add up to 9. Plus 5 plus 4. As I said earlier, you could have it reversed. You could have a plus 4 times a plus 5. It's the same thing. A couple more of these. B squared minus 7b plus 10. Okay, I'm looking for two numbers that multiply to a positive 10 but add up to a negative 7. The two numbers that would do this would be a negative 5 and a negative 2. If you multiply them, you do get a positive 10, but if you add them, you get a negative 7. Oh, I forgot the b squared here. This is a b times a b. Minus 5 minus 2, and we have it factored. Let's squeeze in another one down here. Y squared minus 8y plus 6. Now, what two numbers multiply to a positive 6 but add up to a negative 8? They have to multiply to a 6 but add up to a negative 8. 2 and 3 don't work. Negative 2 and negative 3 don't work. 2 and 4 do not work. Nothing works. Question mark there. Nothing works. Well, if you cannot factor a polynomial, then what we do is we call that polynomial prime. And this is an example right here of a prime polynomial. Okay, cannot factor. Moving on. Factor. M squared plus 2mn minus 8n squared. Okay. Since it starts with an m squared, I'm going to, I know that it has to be m times m here, like that. Now this one's a little bit different from the others because I have another variable involved here. And that is right back here, I have an n squared on the end. Well, don't let that worry you. Just do basically what you did with the front term. Since there's an n squared in the back, I know there has to be an n times an n in the back right there. Now I'm going to do exactly the same thing I've been doing with the numbers. I'm looking for two numbers that multiply to negative 8 but will add up to a positive 2. Two numbers that multiply to negative 8 but add up to positive 2 would be a positive 4 and a negative 2. So I'm going to put plus 4 here and minus 2 right there, and I have it factored. And remember, if you're unsure, you could always FOIL that out to see if it does give you the original polynomial back. And in this case, it would. Here's another one of those. Excuse me. P squared plus 6ap minus 16a squared. So since I do have a p squared in the front, I'm going to make that p times p. And since I have an a squared in the back, that's a times a back here. Now I'm looking for two numbers that multiply to negative 16, but will add up to a positive 6. And those two numbers would be a what? That would be an 8 and a negative 2. And so I'm going to put plus 8 here, minus 2 there, and I have my polynomial factored again. Let's look at this one now. 16y cubed minus 32y squared minus 48y. Now, what you should always look for when you are factoring trinomials, or any polynomial at all actually, the very first thing you should look for is a GCF. If you can factor a GCF out of everything, you should always do that first. Notice that I do have a GCF here. Out of all three terms, I could factor out a 16y. So I'm going to factor 16y out of all the terms. If I do that, that leaves me with y squared in the front, minus a 2y, and then minus, that would be minus 3. Okay, I factor the GCF out right there. There it is. Now after I factor the GCF out, I can attempt to factor the trinomial in here further. The 16y just stays in front like that. Now right here I have y squared, so that's going to be y times y. And I'm looking for two numbers that multiply to negative 3 but add up to negative 2. And those two numbers would be a negative 3 and a positive 1. Those multiply to negative 3 but add up to negative 2. Minus 3 plus 1. And I have my polynomial completely factored. There's the whole thing right there. If I were to multiply that all together, I would get the original polynomial back. Okay. Now let's look at trinomials of the form ax squared plus bx plus c, where a is not 1. In other words, we have something, a leading coefficient other than 1 in front of the x squared term. We handle these a little bit differently than what we've been doing. Here's one way to factor them. I call it the trial and error method. We'll start with 3x squared plus 7x plus 2. Excuse me. Okay, I'm going to draw some parentheses. Now what I do is I start on with the last term, positive 2, and I list out all the ways I could factor a positive 2. Positive 2, it could be 1 times 2. It could be negative 1 times negative 2. That gives you a positive 2, but that's about it. I mean, I could reverse those and write 2 times 1, but it's the same thing. I go to the front term and I do the same. 3x squared. How could I factor 3x squared? Well, I could have 3x times x. You could say negative 3x times negative x, but I've never seen negative numbers used on the front term, so I'm not even going to write those. Now I'm going to take a good guess here. I'm going to try the 3x plus x. So 3x times x. I'm going to write 3x there and x there. And then up here I'm going to pick the 1 and the 2. Plus 1, plus 2 right there. Okay, so I've plugged those in, but I'm not yet sure that I have it factored correctly because I just really guessed. I just randomly put terms in there. So now I'm going to check, and here's how you check. It's part of the FOIL method. I'm going to multiply the inner terms together. That's 1x. And I'm going to multiply the outer terms together. That's 6x. Add those together and you get 7x. If that is the middle term, you've factored it correctly. Notice that I do have it right here. 7x is the correct middle term right up there. And so that tells me that I have factored the polynomial correctly. It's 3x plus 1, x plus 2. Here's another example of that. Put it right here. 3y squared minus 11y minus 4. Starting with negative 4, I'm going to list out all the ways you could factor it. 1 times negative 4, negative 1 times a positive 4, 2 times a negative 2. 3y squared, there's really only one way to do that. A 3y times a 1y. So now I'm going to try the 3y and the 1y here. And then I'm going to pick here. Now remember, I'm going to try to get that middle term. So I'm going to try the 1 and the negative 4. Plus 1 minus 4. And let's see if I have it right. I'm going to check. That's 1y. That's negative 12y. That adds up to negative 11y, and that is the correct middle term right there. That means I have my factorization correct. There it is, right there. If you had added these together and you didn't get the middle term, you would have to back up and try another arrangement. Let's move on. 6k squared minus 19k plus 10. Okay. Factoring positive 10. There's a few ways to do it. I could have 1 times 10. I could have negative 1 times negative 10. I could have 2 times 5. I could have negative 2 times negative 5. Those are all the ways to factor a positive 10. 6k squared. It could be 6k times 1k. Oh, let me fix that. Not showing up clearly here. 6k times 1k. It could be 3k times 2k. Now I'm going to try, let's see here. Let's try the 3k and the 2k. And let's try the minus 5 and the minus 2. Let's see if I guessed correctly. I tried that set and that set. Let's see. That's negative 10k. That times that is negative 6k. Now if I add that up, that's negative 16k. Is that the correct middle term? No, it's not. I need a 19. So I guessed wrong. I'm going to have to back up. Erase, erase, erase. Erase, 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 erase. And I'm going to try a different arrangement here. This time I think what I'll do is I'll try the minus 2 here and the minus 5 there. Just switching those may be all it takes here. Now let's check. That times that is negative 4k. That times that is negative 15k. Add that up and you get negative 19k, and that is the correct middle term. And so there is the correct factorization. And this is why it's called the trial and error method, because sometimes you'll initially guess the wrong arrangement and you have to go back and try another set. All right, here's another one. 12y squared minus 5y minus 2. Negative 2. There's only a couple ways to factor it. It could be 1 times a negative 2 or negative 1 times a positive 2. Front term, 12y squared. There's a few possibilities here. It could be a 12y times a 1y. It could be a 6y times 2y, or it could be a 4y and a 3y. And so I'm going to pick a good guess. And I'm going to try the 4y and the 3y. Usually it's the smaller numbers that work, usually. 4y and 3y. And then seeing that I'm trying to get a negative 5 there for the middle term, I'm going to take the 1 and the negative 2, and I'm going to put the 1 here and the negative 2 there. And I think I have it. I'm going to check. That's 3y. This times this is negative 8y. Add that together and you do get the correct middle term, negative 5y. See, there it is right there. So there's my correct factorization. Excuse me. Let's try one or two more of these. (10x squared plus 17x plus 3). Okay. Positive 3. It could be 1 times 3. It could be negative 1 times negative 3, but if you notice, there's no negative numbers in the polynomial here at all, so I'm not even going to try those. The front term, 10x squared, it could be 10x times 1x, or it could be 5x times 2x. Let's try, I'm going to try the 5x and the 2x, and then I'm going to take the 1 and the 3, and I'm going to put the 1 here, plus 1, and plus 3 there. And let's check and see if we have the correct middle term. That times that is a 2x. This times this is a 15x, and that does add up to 17x. Correct. Correct factorization. Let's try 8t squared minus 13t plus 5 now. All right, positive 5. I could factor that as 1 times 5, or negative 1 times a negative 5. The front term, 8t squared. It could be 8t times 1t, or it could be 4t times 2t. So this time, seeing how I need a negative 13t for the middle term, I'm going to try, let's see here, I'm going to try the 8t and the 1t, and I'm going to try I need some negative numbers here. I'm going to try this one, the negative 1 and the negative 5, but I'm going to put the negative 5 here and the negative 1 there. Let's try this arrangement. Let's see if it gives me the correct middle term. This times this is negative 5t. This times this is negative 8t. And that does add up to the middle term up here, negative 13t. So I have the polynomial factored correctly. Okay, moving on. Let's look at a couple that are a little bit different. Just a little. 7p squared plus 15pq plus 2p squared. Okay, this is one of those trinomials that have the two variables, and so the process really is the same. Let me show you. Start with the last term, 2q squared. How can we factor it? It could be 2q times 1q. It could be negative 2q and negative 1q. That's about it. The front term, 7p squared. 7p times 1p. That's about all that there is. And so I'm going to try the 7p and the 1p. And then I'm going to take the 2q and the 1q, and I need a 15 for the middle term. So I'm going to put the 1q here, and I'm going to put the 2q there. Let's check and see if we have the correct middle term. That times that is 1pq. That times that is 14pq. And that does add up to the correct middle term, 15pq. There's my correct factorization. Here's another here's another example. Excuse me. 12z squared minus 5zy minus 2y squared. Okay. Let's start with the last term. Negative 2y squared can be factored as a negative 2y times a positive 1y, or it could be a positive 2y and a negative 1y. the front term, 12z squared, there's a few options for that. There could be 12z times 1z, could be 6z times 2z, could be 4z times 3z. Okay, so I'm going to take a guess here. I'm going to try the 4z and the 3z, and I could be wrong. It's possible. And I need some negative numbers, so I'm going to try the, well, there are negatives in both of these. Let's try, keep in mind I need a negative 5 for the middle term. I'm going to put the negative 2y here and the positive 1y here. And let's check and see if I have the correct arrangement. That's 3yz, or 3zy. Let me fix that. 3zy. This times this is negative 8zy, and that does add up to the correct middle term, negative 5zy. And there's my factorization. Now, what do we do if we have a negative number in the front, such as this? Excuse me. Well, what you should do is factor negative 1 out first. Factor negative 1 out of all the terms. That leaves me at 6r squared minus a 13r minus a 5. Now I factor the trinomial as I was doing. So I'm going to leave the negative 1 right there in front. Negative 5's got to be 1 times negative 5, or negative 1 times positive 5. 6r squared, 6r times 1r, could be 3r and 2r. Excuse me. And I'm going to try the 3r and the 2r. And I'm going to try the plus 1 here and the minus 5 there. Let's check my middle term. That's a 2r. That's a negative 15r. You add that up, that is negative 13r. It's correct. It's this middle term right there. And so I have the correct factorization. Let me write it out for you. Complete factorization is a negative 1 times a 3r plus 1 times a 2r minus 5. There it is. Okay, so if the leading coefficient is negative, factor a negative 1 out first. Then factor the trinomial. Okay, let's look at this one. Just a couple more to go here. Now, as I mentioned before, really the first step in factoring anything, any polynomial at all, is always to look for a GCF. Notice that this trinomial does have a GCF other than 1. I can factor out how much? I can factor out an 8 and a y out of all the terms. So I'm going to do that first. The leftovers then would be 2y squared plus a 3y minus a 2. Now, once I factor the GCF out, I then attempt to factor the trinomial that's left inside, just like I've been doing. Let's see if it factors. Negative 2 is 1 times negative 2, or negative 1 times positive 2. 2y squared. There's only one way to factor that, 2y times y. So I know it's going to look like that. And I need a positive 3, so I'm going to use this one. I'm going to put minus 1 there and positive 2 there. And just a quick check to see if we have it correct. That's a negative 1y. That's a 4y. And that does add up to the correct middle term, 3y. See right there. And so the complete factorization of this polynomial is 8y times 2y minus 1 times y plus 2. Completely factored. Let's try one more like that. 30y to the 5th minus 55y to the 4th minus 50y cubed. We do have a GCF, which will come out of everything. Looks like I can factor a 5y cubed out of all the terms. Right, 5y cubed. Now if I do that, that leaves me with 6y squared minus 11y minus 10. I'm now going to try to factor the trinomial in here that is left. So let me write this out. Negative 10. It could be 1 times negative 10, negative 1 positive 10, 2 negative 5, negative 2 positive 5. Lots of options. 6y squared. 6y times 1y, 3y times 2y. Now I'm going to try, let's see, what are we going to try here? Let's try the 3y and the 2y. And with that, I'm going to try the, let's see, I need a negative 11. So I'm going to take the 2 and the negative 5, and I'll put the plus 2 here and the minus 5 there. Let's try it. That's 4y. That's negative 15y. Add that up, and that is the correct middle term, negative 11y. There it is right there. And so this is our complete factorization. One more example of factoring a trinomial. 6y to the fourth plus 7y squared minus 20. There is no GCF that I could factor out of everything. So what I'm going to do is just try the same technique I've been using. Negative 20. Let's list it all out. 1 times negative 20, negative 1 positive 20, 2 and negative 10, negative 2 positive 10, 4 negative 5, negative 4 positive 5. Lots of choices there, lots of options. 6y to the fourth power. Now I'm going to factor that y to the fourth as y squareds because you have y squared in the center. So 6y to the fourth could be 6y squared. Let me fix that. It could be 6y squared times a 1y squared. It could be a 3y squared times a 2y squared. And so now it's just a matter of trial and error. Let's see if we can pick the correct arrangement here. I think I'll try the 3y squared and the 2y squared. And keeping in mind I need a 7y squared in the center, I'm going to try the negative 4 and the positive 5 there. Let's check and see if I have the correct middle term. Let me use red for that. This times this is negative 8y squared, and this times this is 15y squared. Add those together, 7y squared, the correct middle term. And so this is our factorization. And that is our lesson on factoring trinomials.